Hello, hello, Godot, Godot. I just wanted to share my little experimentation session with Godot. Um, One reason why I'm looking at Godot is because I've always wanted to, I don't know, check it out just because it seems like a less cluttered platform that seems pretty decent. One of the things that intrigued me about it is the fact that it kind of more innately organizes stuff in a scene in a way that I'm more used to as a web developer by profession. And what I mean by that is, you see over here we have a hierarchical node tree, which is available in most other engines. I'm sure Unreal Engine 3, 4, and 5 did this. Unity does this, but I'm not sure how to describe the difference. It seems like it it works with these trees from the bottom up, if that makes sense, instead of after the fact. And also, all these nodes, similar to a DOM tree, can interact with each other via signals or events in the web world. So you have signals which don't exactly work exactly like a DOM, but they have a similar functionality. So, for instance, there isn't like the default notion that parents will listen to the children's signals. You have to kind of like manually hook them up or find the nodes yourselves and then hook them up. But once they're hooked up, they still kind of act the same way. Um, it doesn't matter where it is; they'll respond to the events being emitted by that component or node in this tree. So what we have here is my main scene. Whenever you start a Godot project, you can pick the main scene, and then that's what will actually get loaded when you hit the play sign here. So I've set up a humanoid scene camera. I noticed that when I just threw a camera in here, it just defaulted to being the one that is used by the rendering debugger. I set up an Omni light just to kind of make it look a little better, but otherwise the ambient light's just fine. You can also, I think you can just hit the cinematic preview to get an idea of what it looks like when the camera's there. I wouldn't say it's as good as Unreal Engine or Unity in this sense because they usually have like a little preview window for the camera that's currently selected, which is nice to be able to rapidly adjust things. But for my purposes, I don't really need that level of detail. So what you'll see when you click these little scene icons is that you'll go into the actual scene that is built up inside of here. And this was one of the things I had a really hard time with in Unreal Engine 4 and 5, which is that when I wanted to structure things and compose them together and then reuse that collection of components somewhere else, Unreal Engine 5 and 4 had a really hard time keeping consistent what I wanted between uh, instances of that structure. And all the resources I found just didn't really answer my questions. It just kind of assumed that you would do everything within the main scene, um, which probably works just fine. But it's not the way I want to organize things. So I found this to be a lot better. So what's nice too is that everything you save here corresponds to this file system area. So like this is the main scene. It's a file that you can edit. Um, the humanoid scene. That's, I believe, yeah, I made a creature's humanoid. Idea being that I could create like maybe a quadruped or an arachnid or, whatever makes sense here. So here you can see that this humanoid body, my idea as before is just to kind of compose it of parts and connect those parts together uh, in a way that I wouldn't have to necessarily care about the internals as long as I structured everything as I desired. So this humanoid scene is just basically the scene root. Then you have a body. The body just wraps everything that composes this humanoid. And then from here we have body parts, the head, the torso, left and right arms, left and right legs. And I also realize that this is incorrect because we're facing, it's not from the point of view of the actual creature, it's from our point of view. But, let's just ignore that for now. Like this is his right hand, not his left hand. It's our point of view that we're looking at. And then The torso has a heart, a shoulder, and a right shoulder, left and right shoulders, and left and right hips. My thought there is that these would serve as the connecting organs to the other parts. And then the head has a similar situation where the neck connects the head to the torso and the brain emits the nerve impulses through the body parts. So this is very similar to how I handled my worm, if you will, in the Unreal Engine 5 video, which I can link to here. And then I decided to just go ahead and start coding up what each of these organs will do in the body system. And what's neat about Godot is that each node can have its own script. So as you can see, these are all individual scenes as well. So if I wanted to edit the brain scene, what you'll see is that I'm actually editing an organ. And an organ is just what it is with a graphic embedded inside of it. So the circle, the sphere you see is the graphic that I assigned to it, which is why the brain and the heart and also all the other parts are from the same shape. I've just skewed them individually. So they all have the same graphic for now. And then we start with the organ script. And one limitation in Godot is that only one node can have one script. But since they have a very robust signaling system, you can pretty much manage that. You can keep your scripts isolated to specific nodes that affect the system. So you can imagine maybe adding more and more things to this organ to facilitate other things that are composable within any given spatial object. So here you see my first bit of Godot script, which looks like Python from what I'm told. I haven't used Python too much, so I'm guessing it is, but they have a couple things that are unique to Godot that make it really nice to use. So for instance, this file, since it extends spatial and is attached to a spatial element or node, the default context is assumed to be spatial. So everything here would be as if you're going self dot whatever, self being an instance of this spatial object. So it keeps you from having to type all that, So if get parents available within the spatial context, you'll be able to have access to it, which it does in this case. So this would be your on load or on ready events, and then your tick event process is basically your tick event. And on ready, and up here you see these exports. This is how you would expose a variable to someone editing the variable. So I have an impulse interval, and then I also have a g.impulse types. And G is defined here in this global script. When you use the class name within a script that you've defined and give it a name, it refers to everything else as if it's in that context. So G I just refer to as a global namespace that I want to use in multiple places, right? And I might pull more into this just to keep it all in one place, but I felt it, nice that I could just create a script that is available everywhere without having to include it. And here I've defined some nerve impulses, some impulse types, none, blood, and nerve, none just being like a default value. So I've set that enumeration type so that when you edit one of these, you can just pick which one of these you can go with. So it has a nice little automatic configuration interface, which is nice. A node path. So a node path, when you do that, you can just assign, I don't know what I did there. Oh, that's the cleanup, I think. You can pick within your node scene what gets assigned here. And here the idea is that you can pick where this organ connects to for the purposes of shoulders, hips, and necks. Impulse type, what kind of impulse does this provide? Interval is, if it's greater than 0, it'll start signaling to other organs around it, to the body parts around it, or anything listening to it, really. What type of impulse is being fed? And then the impulse types are just being defined in the global namespace. I'll just undo what I did to make that change. All right, cool. So the next thing is what I do on ready. Well, let me go through here. This is how you define a signal. I called my signal impulse, and there's two values that I want to make sure are passed through the signal. Then I have a frame count, which I use later for timing out the impulses. And an integrity, which is the idea behind integrity, is how much HP does this organ have left, basically. And I'll get into that later. So then I make sure that I connect to the parent's impulse convey signal, because the body part is also going to convey signals to other body parts. And that's what that's about. Self is the context that this is going to be in, meaning I'm going to be calling self on this method on this object. So this is where I'm actually going to be calling. And this is how you do it programmatically, binding to another event. So whenever the parent fires impulse convey, we're going to get a call to here, which right now doesn't do anything. But as you can see, I can check to see if the originator came from here. And then if so, I can just ignore that so that it's not constantly looping endlessly. Moving on to the tick or process. Godot has this weird thing where if you have a not used, if you don't use a variable within the loop, the function that you're defining, it'll yell at you. Well, it won't yell. It'll kind of like nudge you, say, "Hey, you're not using this." And if you want me to stop bugging you, put an underscore in front of it. That's all. That's really saying right there. So I put an underscore, but typically if you want to use delta, you just remove the underscore and then you use delta as you would expect. So I check to see if impulse interval is greater than 0 during every tick, which is 60 per second, I believe. And I also check to see if integrity is greater than 0, meaning it's not damaged beyond repair, basically. And then if frame count is greater than or equal to impulse interval, I just reset to 0. And then once it resets to 0, I emit the signal impulse, which with type that's configured from itself, the context of this object. And then every frame, I'm just incrementing frame count if there's an impulse at all. And I'm incrementing it by how much integrity it has. And the reason why I'm doing this is because the idea is, let's say you damage it to like 0.5, then the frame count will take longer, which means your pulses will be farther apart. And that to me sounds like a pretty cool simulation of what's actually going on. You get hit in the heart, maybe you get shocked. Its integrity is down to 50%. Now your organs are getting less and less blood impulses to fuel what they're supposed to be able to do. Maybe it triggers your eyes to get blurry or something like that. That's the thought, at least. And that's what's going on here. So the organs all do that, and I've structured the humanoid to have organs in every body part. So they all do something. So like the brain, for instance, is set to an interval of 300. It has a nerve impulse and doesn't connect to anything. Then in the neck, I have no impulse type, but it connects to the torso, which is this guy. The heart, similar to the brain, has an impulse. I made it different just to see what it looks like differently. It's a blood impulse, and it is not connected to anything. The shoulder, left and right, they're connected to the arms, left and right. Hips, left and right, are connected to the legs, left and right. And then left, right, and arms don't do anything yet. So the reason why I'm recording this right now is because I'm about to do a big refactor based on what I've explored here, but I wanted to share what I've done so far just to kind of give you an idea of what I've done. So then on the body part level, what it's doing is it's already looking at all its children, checking all of its children. This is how a loop looks in a Godot script, and I assume it's similar in Python. I check to see if it has a signal impulse, and if it does, I connect to it. And when I do receive an impulse, it fires here. And then this is an example of how they handle string interpolation. So you define a string using tokens, and here's just like $S, %sign S, %sign S, and it gets replaced by, if you put this %sign here, and an array of values, they get replaced one by one in order. So here I want to show from this of type this, which I just grabbed my impulse keys, and then I went to the impulse type being passed through, since this is going to be like 1, 2, 4. And then this is the actual thing that pulsed the event in the first place. So this is a nice handy print to show me that it's working or not. And then I made another signal called impulse convey, providing the type and originator. And what that does for me is allows things that are listening to this, like the organs right now, to listen to it and handle something with it, maybe pass it on to something they're connected to, for instance. So that's all that does. And then we go to the second part, which is these graphics. So the graphics, what I wanted them to do is to connect to the impulse event of their parents on the organs. And then every tick I check to see if if show pulse is turned on. And the process just handles a quick, just gradual interpolation toward a given color. So here I have a base color, blood color of red, nerve color of yellow, and the current color, which is going to be used in the actual material on the organ graphic. And I just have I to iterate through and reset. So if I is greater than 1, so it's going to go from 0 to 1, I reset it to 0, I turn off the pulse, I set the current color to the base color, basically resetting it, and then that's all that does. Everywhere else, if the pulse is turned on, it sets the value of albedo color, which is like diffuse color, or just like the basic color. And then I grab the base color, I interpolate linearly with the color being picked, which changes based on whether or not we have set it to blood color or nerve color. And then I use the I value to return the color value that it would be between 0 and 1. And then I increment I again, and it'll keep doing this every tick until show pulse is false. And then whenever we receive an impulse from the parent, we grab the impulse type. We don't need originator in this case. And then we set the I to 0. We match, and this is Godot scripts, maybe Python scripts, use of switch, basically. We switch on a value, and then you just straight up put the value here, so for each one, and then we just do something on each one. I actually prefer this structure of a switch than most I've seen. It's very flexible. And then at the end of that, I set show pulse to true so that the tick knows to animate the color. And here we go. That's the basic gist of that. And I also do the same thing on this graphic. I basically just copied and pasted what I had over there. I could probably just make it a separate script and then import it here where needed, just like the values I needed. But, I just wanted to get it working to see if it worked. And that's that. So what that means is that in our main scene, when we pull in the humanoid's structured this way, and then when the scene starts, the brain will start, the heart will start, and everything connected to it will receive a impulse. Now, none of the impulses are being conveyed to the other parts of the body, so we'll only see the torso, the head and the brain and the heart emit colors. But I think that's enough. Let's show it off. So we hit play, and as you can see, they're behaving exactly how I expect. And as you can see here, the head, nerve impulse received from brain, torso, blood impulse received from heart. And it's just going every interval. Now they're going at the same time because I didn't put like a delay prior to each reception, so it doesn't like bubble away, if that makes sense. But it's there. And the neat part about this is that I went ahead and set up a HTML export. And as you can see, it's works almost exactly the same. I don't see much of a difference. On top of this, we'll pull up the developer tools. The prints also show up in the console log. So as you might imagine, this could be an actually really good choice for certain 3D applications that you might want to do on the web, because the export is pretty nice. From what I read, though, notice that it starts and stops a server for you internally, is that you have to make sure you're on GLES2 for that to be stable. If you go to 3, I think the lighting isn't as stable. So there's that limitation. But if you're cool with that limitation, you'll have a pretty good way to manage 3D on the web. So pretty exciting. And I definitely have some refactoring to do here, but hopefully you found this useful to check out. And I've enjoyed doing it so far. So thanks for watching. Bye-bye.